Hi everyone. Today's lesson is going to be continuing on the factorisation idea, this time using the perfect square pattern. Now we saw the perfect square pattern yesterday. Today we're going to be running this one in reverse. So we'll be starting with something that looks like what's on the right hand side. Let's do a nice one to begin with. Let's start with x squared plus 6x plus 9. That sounds pretty good. Now, we're looking to see whether this appears to have the same pattern as what's on the right. So is the first part a square? Is the first thing a square? Yes, it sure is. It's x squared. Is the second part a square? The last part a square? Yes, it is. It's 3 squared. So let me just write this down. I've got an x squared there. I'll skip the middle bit for a moment. I've got a 3 squared there. Now that certainly starts to look like the pattern on the right hand side. Now the next bit in the middle I have to check. It's 2 times the first one times the second one. Is the middle 2 times the 3 times the x? Is 2 times 3 times x the same as the 6x that we had? Sure is. So this fits the pattern. And it's the first thing, x, plus the second thing, 3, all squared. That's factorised because we knew from yesterday that expanding it out gave the rule that we have up the top there. So that was a straightforward one. Hopefully that one's okay. Sometimes they get a bit more interesting. Let's try this one. Let's go y squared. Let's go minus 2 x y plus x squared. So we're looking for that pattern where the first thing is squared, the second thing is squared, and the thing in the middle is 2 times the first part times the last part. So let's write that down. Well, the first one is definitely y squared. The middle bit does look like 2 times the first part times the last part, but there's that annoying minus sign there. And then the last bit, what if it were negative x squared? Now a negative x times a negative x becomes a positive x squared. So that's fine. And really what I might want to do is just give myself slightly more room there. I'll just attach the negative sign there to the x. So it's a positive y squared. It's a negative x squared at the end, and the middle part is a 2 times the first bit times the last bit. So that's the pattern. And I'd have to be careful then that I wrote the y first. Adding a negative x is the same as subtract x and squared, and that's factorised using the perfect square pattern. That's lovely. Now let's try one more just for good luck. What if we had something like 16x squared? That should work. I'm trying to manufacture this in my head as I go, so I'm sort of thinking my way through the problem. Let's put a 9 at the end there. They're both squares, and of course that'd be a 24 times an x, I hope. Let's see if I got this right. Now, is the first thing a square? Well, yes, it is 4x squared. Is the last thing a square? Yes, it sure is. It is 3 squared. And if everything's worked, the piece in the middle should be 2 times the bit at the front, the 4x, times the bit at the back, the 3. Now, what is 2 times 4? That's 8. And 8 times 3 is 24. So the thing in the middle that fits the pattern is the same as what it was in the original question. So the thing at the front is the 4x. Add the thing at the back, the 3, and that's my binomial, which is squared as the perfect square. So perfect square factorisation, opposite of what we did yesterday. We have to recognise the pattern on the right hand side of that rule, and then we can go back to the step on the left. Thanks for watching.